Let's do a very simple sum, very easy one. Let's see the sum. It says that ratio of the corresponding sides of two similar triangles is 3:5. Find the ratio of the areas of these triangles. Now, we're talking about two triangles which are similar, and we are talking about the areas of those triangles. That means one thing is clear, we're going to use theorem on areas of similar triangles. And for that, in this sum, we don't have the names. That means one thing is clear, we're going to denote the areas as A1 and A2, and we're going to denote the sides as S1 and S2. So let's write that as the first step. So we write here, let the areas of two similar triangles be A1 and A2, and their corresponding sides be S1 and S2 respectively. What do we know? Let's see what is given. In the first line, we see ratio of the corresponding sides of two similar triangles is 3:5. That means that 3:5 is ratio of the corresponding side. That means S1 is to S2 is given to us as 3:5. So write that. That's the first information which we have. And what we need to find is find the ratio of the areas of these triangles. Ratio of areas, that means we want A1 upon A2. We know both the triangles here are similar, so use the theorem. So as per the theorem, we'll get A1 upon A2 is equal to S1 square upon S2 square, and into bracket we have the reason as theorem on areas of similar triangles. A1 upon A2 we don't know, keep it as it is. So we write A1 upon A2 as it is. S1 upon S2. We have S1 square upon S2 square. Now, one thing very important here. Do we have the individual value of S1 given to us? You will say, yes, we have 3. No. S1 is not 3. S2 is not 5. S1 upon S2 is given as 3 upon 5. It's a ratio which is given as 3 upon 5. So we can't substitute the value of S1 as 3 and S2 as 5. Be careful about this. So how do we write this? So what we do here is when we have S1 square upon S2 square, we'll write it as S1 upon S2 the whole square. Write it as the square of the ratio. Right? Now, is that clear? Now what we can do is S1 upon S2 we know. How much is that? 3 upon 5. So let's substitute that value now. This is very critical step. Very important. Right? A1 upon A2 is equal to 3 upon 5 the whole square. Right? Now we can substitute that value. Now what is A1 upon A2 equal to? Now it's so simple. 3 square is 9 and 5 square is 25. That means now we got the ratio of the areas of two triangles. We can see the final answer there. The ratio of the areas of two similar triangles is 9:25, and we got the answer. Was that easy? Very easy, right?